Welcome to video 4, 11.4, Fundamentals of Probability. Today's focus is going to be theoretical probability. So let's go ahead and get started. So probabilities of events are expressed as numbers ranging from 0 to 1 or as percentages 0% to 100%. The closer the probability of a given event is to 1, the more likely it's going to occur. The closer the probability of a given event is to 0, the less likely it will occur. So now we're going to look at theoretical probability and talk about how we compute that. So let's take a coin, right? You toss a coin, although it is equally likely to land on either heads up, denoted by H, or tails up, denoted by T, the actual outcome is uncertain. So we're going to use some vocabulary. Experiment is any occurrence for which the outcome is uncertain. Okay? A sample space is the set of all possible outcomes of an experiment, and we call that S. And then an event is a subset of a sample space, and we'll call that E. So the set is either heads up or tails up, all right? The event of landing tails up. So this is how we would talk about the event aspect. So what is theoretical probability? Well, theoretical probability is if an event E has N of E equally likely outcomes and its sample space S has a set of S equally likely outcomes, the theoretical probability of event E happening is denoted by this, P of E. So that means probability of this event happening is the number of outcomes in event E over the total number of possible outcomes. So that's our S, this total set, where E is the subset. So let's look at the coin again. The probability of landing tails up. So what are we looking for? Well, I want tails up. So really I could say P of T for tails. And the way we would set it up is the number of outcomes that results in tails up. Well, tails up, it's a two-sided coin, so there's only one possibility that it's going to be tails. What are the total number of outcomes? Well, it could either be tails or it could be heads. So there's two total outcomes in our set. So the probability of landing tails up is 1 over 2. Or we could say 50% if we wanted to talk about it as a percentage. Okay, so let's take a look at some more examples using a die, okay? So a die is rolled once. Find the probability of rolling, first example is a 2. So remember, there's 6 sides on a die, okay? So if I want to know the probability of rolling a 2, I need the number of outcomes that result in a 2 over the total number of possible outcomes. So how many times could we roll a 2 on a die? Only once. There's only 1, 2. How many possible outcomes do we have? Well, there's 6 sides to a die, so we have 6 total outcomes. So we have 1 over 6. If we could simplify that any further, we would. I want you to try example B on your own. Set it up and find the probability of rolling a number less than a 4. Okay, did you get what I get? I got 1/2. So my E, my possible outcomes, right? The outcomes that result in less than a 4. I only have a 1, a 2, or a 3 that's less than a 4. So how many outcomes are there? There's only 3 possible outcomes that result in a number less than 4, okay? So how many total outcomes are there? Again, there's 6 because it's a 6-sided die. So the probability of rolling less than a 4 is 3 over 6, and we always simplify that to whatever we can, and in this case, it's 1/2. Try part C on your own, a number greater than 2. So figure out what your E is, how many possible outcomes that result in a number greater than a 2 over your total possible outcomes. Okay, here was my set E. I had 3, 4, 5, and 6 are all numbers that are greater than 2. So that really is 4 outcomes that would result in a number greater than 2. There's a total of 6 outcomes possible. So the probability of rolling a number greater than a 2 simplifies to 2/3. Okay, the last example here is a number less than 7. So go ahead, set that up, see what you get. Well, hopefully you got 1 as your answer, or 100%. You will always roll a number less than a 7. So if you wanted to talk about your subset E, how many numbers, or what are your possibilities for numbers less than a 7? Well, every number on the die. Okay, so there's 6 total possibilities of rolling a number less than 7, and there's only 6 total possible outcomes on a die. So rolling a number less than a 7 is 6/6 or 1. Simply 100%, you will always roll a number less than 7 given a 6-sided die. A lot of times in probability, we deal with decks of cards and a standard 52 deck. Okay, a standard 52 card deck. So you have to familiarize yourself, or you have to know what a standard deck is made of. So first, it's made up of 4 suits. 2 are black, 2 are red. The black suits are clubs and spades. The red are hearts and diamonds. Each suit has 13 cards that go from numbers 2 through 10, then jack, queen, king, and ace. So make sure you know this information. If not, write it down now. So now let's go ahead and get into our first example, that we are dealt a 1 card from a standard 52 deck. Find the probability of being dealt an ace. Okay, so the event that I'm looking for is an ace. I want an ace out of the entire deck. So we have to think about, well, how many aces are there? Well, there is 1 ace in each suit. There are 4 suits in a deck. So the number of aces in a deck is 4. So the probability of pulling out an ace is going to be 4 over the total number of cards in my deck, 52. So I got 1 out of 13 chance of pulling an ace out of the deck. Okay? All right. Let's try a red card. What is the probability for part B of pulling out a red card? Give it a try and let's check. Okay, so a red card, remember the decks are made up of 4 suits. 2 are black, 2 are red. So the number of red cards that there are in a deck is 26. So the probability of pulling a red card is going to be 26 over 52, or simply 1/2. We could even say 50% if we wanted to. Go ahead and try part C. Now what's the probability of pulling out a red king? So first we have to determine, well, how many red kings are there? Well, since there's 2 red suits and there's only 1 king in each of those suits, there's a total of 2 red kings in the entire deck. So the probability of pulling a red king is going to be 2 out of 52, or simply 1 out of 26. This last example deals with genetics, okay, and genes and things being passed down from parents to children. So let's take a look. If each parent carries 1 cystic fibrosis gene, we'll call that capital C is the carrier. All right, so capital C represents our carrier here. Okay, what we want to do is we want to find the probability that their child will be a carrier of the disease who is not actually sick. So again, we're looking for the child to have a big C and a little c. Okay, that's what this is indicating. So I want to know, what's the event of being a carrier? How many possible carriers do we have? Well, if we take a look at our chart, this child is a carrier and this child is a carrier. The 2 big C's mean that they have the disease, and the 2 little c's mean they are not carriers. Okay, so if I want to know the probability of being a carrier, I take the 2, that's the probability of the event, how many outcomes in the event, over the total number of outcomes. So 1, 2, 3, 4 possibilities. So that child has a 1 out of 2 chance of inheriting or being a carrier, okay, or a 50% chance. We're going to stop here today. We will finish these notes in video 8. So you will have to come back to this note sheet for the rest. For now, if you have any questions, make sure you ask in class.